Hello and welcome to another video of CH Weather. It's been a long time of some pretty stable and calm weather across the continental United States, lower 48, but we're definitely changing into a pattern with a lot more cold air coming down from Canada, a lot of warm areas. Basically, the trough is turning it, the jet stream is turning into a very wavy pattern, which could bring a lot of storms to the U.S. So, first time we are actually seeing a pretty good chance of severe weather, including that chance of tornadoes or just spinning storms in general, is the day 3 outlook. Sorry, I haven't made one of these videos in a long time. This is for October, let's see, it's day 3, October 19th, which will be Saturday, and you can see there's a slight risk over Memphis, Little Rock, Shreveport, just the Arklatex region. The slight risk consists of all of Arkansas, Missouri, Illinois, tiny little sliver of Indiana, Kentucky, Tennessee, Mississippi, Louisiana, Texas, and Oklahoma. And since this is day 3, all we have is a probabilistic outlook, which just states, again, that 15% risk of severe weather. This has been a risk of severe weather since I think it was day 6, so it was a pretty rare day 6 outlook. So we definitely have confidence that something will happen. And then you also have this marginal risk that surrounds areas like that, reaching into Ohio and all the way back down to near Dallas, Texas. So those areas also need to be watched out, because if anything, somewhere in this light risk could possibly get upgraded to an enhanced risk, and somewhere in here could look at an upgrade to a slight risk. Not guaranteed though. That's why we'll be looking at the models to really look at that. But first, let's take a look at the discussion. Again, there's a slight risk of severe thunderstorms from the Arklatex across the Ozarks and into parts of middle to lower Mississippi and Ohio valleys. So basically, we're just looking at scattered severe thunderstorms across the Arklatex, and again, lower Ohio valleys, and all severe hazards will be possible. Again, considerable uncertainty exists regarding the degree, so we don't really know how severe these storms are going to be, especially on Saturday. Model solutions aren't really agreeing on anything right now, especially within the early day precipitation, because basically what happens is if in the morning, if any of these areas have storms or just general rain move through the area, that's going to stabilize the atmosphere significantly. And if we don't have enough daytime heating after that, or if the clouds stick around, it's going to significantly decrease this risk of severe weather. We might not even see anything at all. So this early day precipitation is definitely, and with a lot of severe weather setups, early day precipitation, cloud cover, like that kind of stuff does determine the severe risk. So that's why right now broad slight risk is given. Then that's just the synopsis. On the large scale, let's see. It's got a trough digging through the Rockies. It's going to come into the Arklatex region. It's going to bring a plume of high dew points, Cape reaching from 1,000 joules per kilogram to up to 2,000 joules per kilogram, and plenty of wind shear as well. Like what I just said, low level moisture, instability, which is the Cape values. Early ongoing thunderstorms become more organized as the cold front strengthens with increasing large scale extent, leading to wind damage potential. So basically what it's saying here is, as this cold front strengthens and moves through the severe weather sector, it's basically going to turn these storms from a more localized, maybe supercellular threat quickly into a congealed line, which will definitely bring more of a wind damage potential. Strong instability. Yeah, if there aren't any storms in the morning, then strong instability could bring during the day, which would bring more of a supercell risk with more tornado and hail. So this was updated a little bit ago, and basically what the update was is, I don't think this slight risk changed at all, but the marginal risk did actually extend a little more north and east into parts of Ohio. That's one thing I noticed since I am in Ohio. I'm keeping a close eye on this as well. So first, the highest resolution model that goes the furthest right now is the NAM 3 kilometer, which covers the CONUS, basically just severe weather sector of the United States. Let's see if I can't tell if that's easy to see or not. I have a really wide computer screen, so it's like, it's weird. Yeah, okay, so moving straight on, basically what we're just looking at right now is just the reflectivity. And, jeez, well, let me do it. But as you get this, let's see. Yeah. You get this trough that's coming down. You can see with these lines, you get that trough, and you have the ridge, and where these interact is where you get those lines of thunderstorms. You have the deepening low across parts of Oklahoma. Basically, as that moves to the east, propagates to the east, you can see the storms congeal into lines all the way from northern Ohio all the way down to the slight risk. You can see where that slight risk is issued. I think it's slight risk encompasses this area. You can see, especially down here, this model shows most of the stronger storms congealing into a line. Southern Arkansas, northern Louisiana. How do I delete these? Control Q. Cool. I'm still trying to remember these things. You know. So the furthest it goes is here, which is where it's going through bits of Indiana. See, it still looks pretty isolated storms along this line as well, going all the way down into the slight risk all the way down here. Now I do want to take a look at some of the soundings that it won't let me scroll up. Sorry, this is probably not very comfortable viewing experience for your eyes. But let's just take a look down here in Waco, Texas, or near Dallas, Texas. This is just stating marginal severe. Not a very high tornado risk at all. Let's see. You do have Cape values that are plenty for. Can I make this less thick? Sorry. Plenty for thunderstorms, but then this photograph up here is very it's more linear. You're not really seeing any curved values. So not a lot of wind shear, especially you can see here. There's some low level wind shear, but overall they're mostly in this direction. That's not what I meant to do. I can move forward to the next scan. As the storms move closer, we might see some of this stuff change. Yeah. You see, as that cold front moves through, you still have that amount of Cape, which is sufficient for thunderstorms. The 3 Cape, where's that at? 131, which is pretty good. It's sufficient for thunderstorms. But one thing I do notice is there's a lot more. Well, I wouldn't say a lot more, but there is more low-level wind shear. You can see this red line. I think that's the 0 to 1 kilometer. It's either 0 to 1 or 0 to 3 kilometer. It's much more curved, and basically, in the simplest way, when you're looking at a hodograph, you want to see curved hodograph for tornadoes. So basically something like that. You can see that red one is indeed curved, so that does indicate the presence of a little bit more rotation. Oh, didn't erase that one. But yeah, that's basically what it looks like for Dallas. Now, I mean, again, this can change. These models are definitely not agreeing right now. We're definitely way too far out to look right now. So I'm just kind of looking for general stuff. So if you look into, let's go Central Arkansas. Trying to find a reliable sounding. Because when you see these red bars right here going past the omega line, this just means there's a convective, forget what it's called, convective interference is what I'm going to call it. It's not a reliable sounding. It messes everything up. But I'll look at this one since there's only a little bit of lower level convective interference. So again, Cape values of around 1,000, which are sufficient for thunderstorms. 3 Cape at 104. This photograph is more curved, so there's definitely a little bit more wind shear there. And if you look at the effective layer, STP, which stands for significant tornado parameter, see that's a little bit higher, stating the potential for mostly weaker tornadoes, but there's also that small potential of a stronger tornado. So really, all we can conclude from anything seeing on this is that there's definitely a chance of severe weather. Isolated damaging winds are definitely a possibility, but also that possibility of a isolated tornado. Most of them will probably be pretty weak, but you do have the potential for a isolated strong tornado. So that's in Arkansas. I want to take a look up. So this is as far past as it goes, but I want to take a look at southern tip of Indiana. Again, marginal severe. Let's see, actually, looking at this, I think one of the reasons, one thing you'd look at this, you'd be like, geez, there's literally no cape. 155 cape and a 3 cape of 6. That's extremely low. This is very early in the day. The storms are still hours away, so this cape would definitely probably increase as the daytime heating affects it. So, honestly, can't really look at any of the soundings over in this area of the Ohio Valley right now. Can really only see this area, especially where we can kind of get an idea of the exact severe weather potential. But you can see the storms start to congeal into a line and get pretty wavy, quasi-linear convective system, and along those waves you can get those strengthening winds. If I change, I like this website more for it's this one for the jet stream. So basically you can see here's the jet stream, very wavy pattern. A lot of this so far this summer we've seen, I need to change the color. We've seen very high ridges, which has just kept the lower 48 extremely warm through most of the summer. But now we're entering into more of that wavy pattern, kind of the second severe weather kind of time of the U.S., which is this fall time. And this is the trough that brings the severe weather. So looking here, basically, we have this ridge that builds up across the Ohio Valley, and that brings up all of the strong moisture and dew points from the Gulf of Mexico and brings that all the way up and makes this entire area much warmer. And then as you continue to go, you can see that trough slam straight into that area. See along the divergence, which is right here along the divergence, which gives that a little bit of lift. And you also just have the general trough bringing cold air all the way down along this line with the low pressure system. That's all going to interact and bring all the storms. So basically we're just looking, we see a really wavy pattern. You see a trough dig down into a ridge. You can assume that's going to probably produce some storms based off of just their interactions. If you keep looking, you can see that wavy pattern continues. Again, here you got that trough that digs down, more ridges, more troughs. It's a very wavy pattern, especially here. You can see pretty far out. Just an extremely high ridge that goes into a low trough. So we're entering more of a active severe weather season, and really just a weather season in general. We're going to see more times of cold, very cold, and times of very warm, like back to back. I know a lot of states, like where I am in Ohio, everybody's like, the weather's so bipolar here. One day it can be extremely cold, and the next day it feels like summer. It's going to be like that for a lot of us, just because this jet stream is going to be so extremely wavy. It's going to bring very crazy temperatures to everywhere. I want to focus a little more on the severe weather threat and look more at the, let's see, tornadic potential. Or first off, let's look at the cloud cover. This can kind of determine if there's going to be daytime heating. See, there's some scattered clouds over the Ohio Valley. So that's one thing about this marginal risk. You have this slight risk down here, and it's we're pretty confident in that slight risk because, there is going to be daytime heating and instability. So it's pretty likely that storms will form and move across this area. But as you get more north towards the Ohio Valley, this cloud cover and early morning precipitation is going to have a much greater effect on the storms and the severity of the storms. So that's why one reason there's a marginal risk all the way up here is because there is that chance of severe weather, but it's just there's a very high uncertainty in what's going to happen. I also want to look at the dew points. These are important when forecasting severe weather. You can see, just looking at these dew points, you got the trough that digs across, and you got that ridge all the way across the eastern United States, which again draws all that moisture from the Gulf of Mexico. You see this moisture is reaching as high as Wisconsin. Trying to do this as quick as I can. And you got these moisture values very high moisture values. I mean, we're getting 69 in central Arkansas, up to 70 in the Arklatex region, and all the way up to the mid 60s in the Ohio Valley, which is supportive of severe weather. It's definitely high enough anywhere this blue. And then you get that mixture with this sharp gradient. You can see actually kind of right here, you can see this line where it goes from very sharp dew points to kind of lower dew points where the storms are moving through. So we got plenty of dew points for severe weather. It's like if I pick this region, this sounding's probably going to be a pretty high chance of severe weather. Yeah. The only problem is it does have that convective influence, so we can't really trust it. Going back to the severe weather, we look at surface-based CAPE. CAPE values aren't as high, but they are conducive for thunderstorms. Anywhere in the dark gray is enough instability to support thunderstorms, but just the brighter the colors, the easier it is for the storms to become strong. You can see the brighter colors are down here. Also, geez, I'm looking at surface-based CAPE, so also all these values are going to be lower. If I look at the mixed level CAPE, we'll probably see a little bit more. See just general around 1,000, 1,500 joules per kilogram, and then 1,000 to a little less than 1,000 all the way up across the sector. Looked at these before. I thought they were a little higher, but they don't look very high. I want to take a look at, so that's the NAM 3 kilometer. If I just look at the NAM, I wonder what it thinks. Yeah. So you can see the models they're not really agreeing on a lot of the ingredients. You can see, they did both agree with a lot of CAPE over Oklahoma, but the NAM 3 kilometer, the convective one, said once it reaches Arkansas, it's pretty much going to completely die out. But this one keeps a little spot of almost 3,000 joules per kilogram in Arkansas. So again, I mean, looking at this one, this is a extremely tornadic environment. Again, this could absolutely not happen at all. This could be significantly less. But look at this photograph. Extremely curved, lots of wind shear, and lots of CAPE as well. So these storms are going to be explosive in nature. But I cannot stress enough, this could just be completely wrong because the models are kind of all over the place right now with what we're looking at. All we really know is that there's a chance of severe weather. We don't really know the specifics of the severe weather. And as we get closer to the moment, so tomorrow, the day after that, and then just tomorrow, and then the actual day of, we will actually know what the specifics are of the severe weather, what we can expect, and also especially where we can expect. So I don't want to dig too deep into it, but basically we're just looking at, we have the instability in the atmosphere. We have a low pressure system and a trough digging through. We have high dew points. We have high wind shear. So all of the ingredients are coming together for severe storms all across this area. I'll pull it up again. The slight risk and the marginal risk. So we have all the ingredients in place, especially the slight risk. Mostly, I'd say this is based off of uncertainty. We're just not really sure exactly what's going to happen and the exact risks. So thank you for watching. I hope this was helpful. If you're a weather enthusiast, if I said anything wrong or inaccurate, please let me know, because I'm not perfect and I would love to learn more. So if I said something wrong, please correct me. But otherwise, thanks for watching, and see you tomorrow.